At the Department of Computing, we have a number of functions that are laid out clearly. One of them is teaching, the other one is research and community work. We have a number of projects under research taken up by our professors and our faculty members in various sectors, trying of course to see how they can contribute to the growth of the country. As you all know, one area that has really had a lot of immense growth is the area of AI, and the impact is heavy. So AI, robotics and such. And there are a number of solutions that are coming up around the innovations in that space. So this project entails seeing how we can be able to improve, maybe look at some of the diseases like autism in children, and see how is it possible that we can induce a behavior, a positive behavior, or they can learn from the actions of the robot. Here is the thing, a robot is generally has the benefits of what you would consider a computer to have. Would not get tired, we can be able to program it, and now is an example of such. So our researchers are working within the space of trying to see how that we can model behavior that can be used, that we can be able to train kids with autism, and how they can be able maybe to gaze on important things in knowing what autism means, that they are not able to relate very well emotionally with what is happening. So we can be able to guide them on how activities that they can carry out so that they improve their ability to interact with the world. That's generally what this project entails. The other projects that are taken is the issue of 3D printing. Big area, because now we can be able to design our own specific components that we can be able to build blocks of bigger things. So we have training in the use of 3D printing. We also have some projects related to the issues around printing of components that will help us build more things. It's like a creator space, trying to see what are some of the things that we can think of as students, as researchers, and build alongside that.
This robot is a humanoid robot, which is social, and the way it works is that it has various capabilities from vision. There are two cameras that you can see here, speakers which you can see here, microphones which you can see here. So it's possible to speak to it, to hear from it. At the same time, it's possible to use its vision capabilities to detect some things. Let's say objects, you want it to recognize human beings or letters or certain unique objects.
It's very, very programmable. And as we have seen, it has various sensors, and it can also be able to move. For instance, when you even perform actions like making facial expressions through gazes, it can also perform some dances and bodily movements. And these can now be applied where we have like children with autism, or even in classroom environments where it can actually be applied to actually teach. It also has the audio sensors and speech input, and therefore it can be able to even be used in a classroom environment to actually teach a lesson.
I've more than 7,000 brothers and sisters in use all around the world, in universities and research laboratories. Do you want more technical details?
Yes.
All right.
What you have seen from the computing department at JKUAT really amplifies what JKUAT is known for, especially on the sense of tech. We are ready to go, and as you know, tech is now permeating every space that we are talking about. So my argument is that whatever we are doing here is, number one, very relevant to our society, number two, very important, and also very interesting. As you can see, students are working with some of the best ideas and the best technology. You don't need to go to MIT to get what we are doing here. We can be able to bring MIT in our labs, and that's a very important thing. Thank you.
JKUAT, setting trends in higher education, research, innovation, and entrepreneurship.